Hi students, this is AJ sir. Let's study 10th standard ICSE math exercise 18b, circles, tangents and chords. Math exercise 18b, theorem number 12. If there are two chords of a circle which intersect internally, then the product of the lengths of their segments is equal. That means here, if chords AB and CD are intersecting internally, that is inside the circle at point P, then we can say that PA into PB is equal to PC into PD. Now remember, if it's small part into big part, it will be equal to small part into big part. Similarly, if they are meeting externally, that is after extending the chord, they are meeting at P. Even here we can say PA into PB is equal to PC into PD. Next theorem states that angles in alternate segments are equal. That means angle CAP is equal to angle CBA. Notice that CAP is cutting the arc CA and CBA is also cutting the arc CA. So that's a good way to recognize equal angles if they are cutting the same arc. Earlier we had a theorem that angles in the same segment are equal. Now we are saying that angles in the alternate segments are equal. Notice that angle CAP has one arm AP as a tangent. Only then this would work. Can you recognize another pair of equal angles which are in alternate segment out here? Well, it will be angle BAQ is equal to angle BCA. Notice that BAQ is cutting the arc BA and AQ is a tangent, and BCA is also cutting the arc BA, hence they are equal. Next theorem. Now if there is a chord, let's say chord AB, and there is a tangent TP, if I extend the chord, they will intersect at point P. So we can now say that PA into PB is equal to PT into PT. Derivations are not there, but you can guess that this is derived using similarity. Now out of the solved examples, let's cancel all the proving sums because it's not there in the reduced syllabus. So SE number 9 is cancelled. 10, 11, 12, 13, 14, 15, 16 are also cancelled. That means only SE number 8 is there in our reduced syllabus. Similarly, in exercise 18b, many sums are cancelled. 1.2 is cancelled. 5th question, 6th question, 7th, 8th, 9th, 11th, 12th, 13th, 14.2 is cancelled, 15th is cancelled. That makes it very small, isn't it? Let's do 1.3. Now, the moment you see this, what comes to your mind? Theorem number 14, I guess. Yep. It says that PB into PA is equal to PT into PT. Notice that PT is a tangent and AB is a chord extended to meet the tangent at point P. Only then the theorem works. So out of these things, PT's value is given, PA's value is given, you can find PB, and name of the theorem is secant tangent theorem. Secant is simply the line cutting the circle in 2 points. That is the extended chord. Now, question number 3. This is given as 30. This is given as 60. We have to find, first of all, QAB. That's this one, this angle. Now, do you see any angle which cuts the same arc as QAB does? QAB, by the way, is cutting the arc AB. Which other angle in the circumference is cutting the arc AB? Yes, angle ADB is cutting the same arc. So they are in alternate segments, and so this will also be 30. Next, angle PAD. PAD. So do you see any angle cutting the same arc as PAD? That is arc AD. Well, angle DBA will be equal to angle DAP, because all angles in the alternate segments. But how do I find DBA? Well, in triangle ADB, I know that this is 30 and this is 90 because it's an angle in a circumcircle. So by angle sum property, this comes out to be 60. So this will also be 60. Next, angle CDB, this angle. Again, same logic. If this is 60 and this is 90 again, angle in a semicircle. So this will be 30 by angle sum property. Here are the steps. Next question is question 10. The diagram is given. They are saying that angle BCG, this entirely is 108. That means by linear pair, this will be 72. So far so good. The chords are equal. First they want to find BCT now. BCT, how do I find that? Well, I see there is a tangent. So if I can draw from the radius, I know that it would be 90 degrees, but that doesn't seem to be of any use. Keep trying, keep thinking. Cyclic quadrilateral property won't help. BCT. Is there any other chord which cuts angle BCT's arc? Any other angle? Yep, if I could draw DB, then angle BDC will be equal to BCT, but I don't even know BDC angle. Well, we could find it in the isosceles triangle CBD. If I know that this is 72, then I can find this angle and this angle as x and x and angle sum property. So I can get, I guess it's 54 and 54, and if this is 54, then this is also 54, and if this is 54, then this is also 54. It's not surprising that these two angles are equal, that is angle DC whatever x and BCT are both 54, because DC and BC are equal chords, and equal chords create equal angles with the tangent. So we could have used that property directly to say this is x, and total angles on a straight line is 180, so 54, 54. Or you can join BD and use isosceles triangle property, x and x, get 54, 54. This is equal to this, angles in the alternate segments. This is equal to this, angles in alternate segment. But then they want DOC also. DOC, it's a central angle. So how do I find that? Well, definitely DOC will be double of DBC, because the central angle is double of angle at the circumference. So this is 54, right? We just found it out. So this will be double of that, 108. Done. Wow, that's nice. I just solved it with a different method. So you can even refer to the different method that I have solved. What I did is I first found this as 72, and then I said that this is x and this is also x, because they are angles created by equal chords with the same tangent. And then this is totally 180, so x plus 72 plus x is 180, so x comes out to be 54. I got this as 54, I got this as 54. Then since this is 54, I said that this is also 54, angles in alternate segments. And since this is 54, I said that this is 108, since central angle is double of this angle. So you can use any method that strikes you. You have to keep experimenting with the various theorems, but the important thing is that the logic should be rock solid and the statements should be crystal clear with all the reasons mentioned. And finally, the 14th sum. Here they are chords intersecting internally, so we know that AD into DE will be equal to BD into DC. So the thing is, here BD and DC is given, DE is asked, but AD is not given. If only they could give us AD, then it will be so simple. However, we can use Pythagoras theorem here because they have given AB, so we can use Pythagoras theorem here to get AD as 3, and then we use a usual theorem, since the chords are intersecting internally, Out of the 4 values, 3 values we know, so we can find the 4th value and the sum is over. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.